So then the second example I want to talk about is bi-temporality. Now, if people work with relational databases and they do a lot of temporal work with databases, then they might know about this phenomenon. But most people are kind of unfamiliar with it. The Wikipedia has a reasonably good explanation of what temporal databases do and what bi-temporality is. The core of bi-temporality is that you might have a fact that has a certain valid time, so something is true from the start point to an end point. But there's also a transaction time when you record that something is true. And when you work with temporal data, you combine both the valid time and the transaction time. Yeah? So this is a little bit abstract, so let's look at where is this important? Well, it's important in intelligence agencies. Yeah? When did we think that a person was where during what time interval? And what happened to inferences made based on earlier incorrect knowledge? So this is one area where this is important. Or you might look at the medical domain. Yeah, we had a patient with a spell of dizziness during the last 6 months, so we proposed treatment X. Now we know he had it only for the last 2 weeks. So what do we do about the treatment? Or financial. We could say, so we have 2 overlapping loans. Others record at different times. Which one was true at the moment of accepting a loan? So these are all kind of things that people in the real world have to deal with when they deal with time. And there's a really good overview paper by a company called Capgemini that wrote this report, Enhancing Time Series Data by Applying Bi-Temporality, with this great title. It's not just what you know, it's also when you know it. So I would recommend that you find this thing on Google. But let me go a little bit deeper for the nerds in the audience. Yeah, how do we deal with bi-temporality in a triple store, and how do we use property graphs? Yeah? So say I want to add some facts about where a person works, who a person works for what department in an HR database. Now I can add some bi-temporal facts like person 1 worked in January and February for Department 1, which is the black one, and then he worked in March and April for Department 2, and we recorded both these facts on the 1st of January 2013. But then later, we figured out that we made a mistake, and we put in the database that this person actually worked in February and March for Department 1. Yeah? So now, in a company where you can work only for one department at a time, we have a problem. Yeah? Because here, the database is inconsistent. So how would you even find this inconsistency in the database? Well, you can do this with 2 representations. The first one would again be a property graph. So you would say person 1 works for department 1, and the 4th element of the triple would be statement 1. And then you would say, well, statement 1 is a start point T1, end point T3, and the recording time was T100. And then we would say person 1 works for department 2 at statement 2, where the start point was T3, end point T5, and the recording time was the same time as here. But we also added the statement that this statement is currently true. Yeah? It's very important to remember that we take a little bit of pain when we add these facts to the database and do a little bit of processing to make sure that we always know what the most current truth is about a certain matter. And why this is important, I'll talk about it later. Then here we get the conflicting statement where we say that the person actually worked from T2 4. Now this is representing this data using property graphs. You could do the same thing with events, how we usually do things. We have events of type work for, the actor is person 1, and where is department 1, and then the same things that you saw above. But for now, let's just focus on the top part. Yeah? So the first thing that I just said is that you saw that some of these statements had the feature that, the property graph had the feature that it was the current statements. And why that is important is, well, we were working with some customer databases where you had many statements, many statements about something recorded at different times. Then you could get, when you did the queries, you had to always look up what is the most recent belief that we have about what is true. And so we have to do Sparkle queries where we say, well, find the graph where person 1 works for department 1 and works for department 2, and they're not the same. And then we wanted to know, okay, but which one is the last time, yeah, when we knew about it. So we had to do a subquery here, a subquery there, and then we had to do a long filter expression to figure out whether there was an overlap. So what we did is we add a little bit of magic. So this is again the same thing. We find the two graphs. If something is true, we take filter. And now it looks a little bit prettier here. Let me secure here. Oh, sorry, this was wrong. Look here how in this particular frame we have to look at the particular graphs, and then we have to look up the start points. Yeah, so that's a lot of work. So what we can do is we have temporal predicates in Sparkle, and this is actually predicate here. So we can say now we don't have to look at all these things here to figure out when the dates were actually. We can just say did graph 1 and graph 2 overlap. Yeah? So now it's starting to become more readable. That can be even more readable if we use another magic predicate that we're going to introduce in the product, which is current. So we say, give me the most current statements for this, give me the most current statement for this statement, and then is there a temporal overlap between the two? And now you kind of have a chance of understanding what the query is about.